Hello, and welcome to the Dental Learning Center. I'm Dr. Junior Poser. With me today is Dr. Marie Huggy. Dr. Huggy is an expert in dental education, having spent over 25 years educating over half the dentists in this state. So, welcome, Dr. Huggy. Today we're going to be talking about porcelain fused to metal crown tooth preparations, the errors that can contribute to their failure.
Hello, Junior. It's great to be with you on the Dental Learning Center today. The errors we are going to discuss are under the control of the dentist. While we are referring mainly to anterior PFM tooth preparations, these errors apply also to posterior teeth.
Teeth requiring crowns have frequently been compromised in some way, and it's hard to attain the ideal outline form. The Dental Learning Center has made some other videos that might be helpful in this regard, but it's always a good idea to learn what a good preparation looks like. This slide illustrates the failure to provide adequate reduction of the incisal 1/3 of the labial surface. The result is insufficient space for a thick enough layer of body porcelain to neutralize the opaque porcelain, and this will ruin the cosmetic effect of the completed facing. Trying to mask this opaque area with porcelain stain or by adding body porcelain results in over-contouring and will rarely remedy this situation. The only effective method of correcting this error is to adjust the preparation and fabricate another restoration. This slide illustrates over-reducing the incisal surface to ensure adequate translucency in this area. The shortness of the preparation decreases the retentive qualities of the crown, and an area of unsupported porcelain is likely to fracture. It has been observed that in any stress-bearing area of porcelain in excess of 2 millimeters is liable to fracture. So in order to prevent a fracture, one would have to extend the coping longer, which defeats the purpose of over-reduction of the tooth. So using depth guides to establish the reduction along with a putty reduction guide is useful to prevent this type of error. This slide illustrates a chamfer finish line with inadequate width. The metal casting fabricated for this preparation may have good marginal integrity when tried on the prepared tooth. However, when the metal is taken through firing cycles of porcelain, a strong contraction shrinkage of the porcelain can deform the thin metal, resulting in an open margin on the completed restoration. Another error that is possible when reducing the incisal edge is to approach the incisal edge with the burr at the incorrect angle. The burr is correctly held parallel to the terminal protrusive pathway, which is basically perpendicular to the opposing tooth, the longitudinal axis of the opposing tooth, and 1.5 to 2 millimeter depth grooves are placed. The width of the burr can be measured with a gold gauge, and the burr can be used to guide the depth of tooth removal. When done incorrectly, this results in over-reduction of the tooth, inadequate length, and loss of retention. So remember to hold the burr at the correct angle and use depth guides to do your incisal edge reduction. This slide illustrates the chamfer margin when the cutting instrument is inserted into the tooth beyond 1/2 of its diameter. This is sometimes called lipping or a J-shaped margin. It is unacceptable as a finish line and must be corrected. The restoration cannot be fabricated with this particular margin because the die typically will fracture right at the margin at some point, whether it's when it's being trimmed or whether it's being waxed. So this margin has to be corrected. Now it can be avoided by using a K-type gingival curettage diamond to eliminate the lip. Sometimes you can bevel it with a flame-shaped burr to remove this external defect, but the lip is unacceptable and has to be corrected. When a tooth is being prepared to receive a crown with an aesthetic veneer, the facial surface should be reduced in 2 planes. One plane is nearly parallel with the path of insertion, that is, with the longitudinal axis of the tooth, and the other one is parallel to the incisal 1/3 of the facial surface of the tooth, or parallel to the external surface of the tooth. So that is illustrated in figure A, the correct reduction of the labial surface. In figure B, you can see that there's only one plane reduction. That reduction was carried out, which results in insufficient space for porcelain in the incisal 1/3. This is a very common error. In figure C, the reduction was in the incisal 1/3, extending the entire length of the tooth. This can result in a pulpal exposure, an over-reduction of the tooth, and so this is an incorrect way to reduce the labial surface. So the correct way is in A, and all the teeth should be reduced in 2 planes. A plane first parallel to the longitudinal axis of the tooth, and then another plane in the incisal 1/3 parallel to the external surface of the tooth. Necessary to form the lingual surface of an anterior tooth so that there is a vertical wall on the lingual surface of the cingulum and a separate concave surface incisal to it. This provides step-like resisting areas to counteract the tipping effect of forces from the lingual. The lingual concavity also creates space for a crown with proper contours and occlusion with minimal removal of tooth structure. If the lingual surface is formed into a single sloping plane, the arcs of rotation of all points in the crown will be either parallel with or directed away from the tooth, and the crown, lacking resistance form, will fail.
I'd like to point out that in the ideal preparation the cingulum wall parallels the labial gingival wall, with a 6-degree taper. This taper provides resistance to displacement along the path of insertion, as well as resistance to off-axis forces. When adequate retention and resistance form cannot be obtained, one should consider placing axial grooves. Of course, in extreme cases endodontic treatment with placement of a post and core may be considered, provided adequate ferrule can be developed. The illustration is intended to demonstrate the resistance form of an optimally designed cingulum wall. As biting force is applied to the lingual, the cingulum resists rotation of the restoration about the fulcrum, labeled with the letter F. By comparison, The lack of resistance form in the absence of a cingulum wall permits rotation about the fulcrum, labeled with the letter F, with eventual dislodgement of the restoration.
Of course, one frequently overlooked issue is failure to obtain sufficient reduction for the restoration. Sufficient reduction is critical, and several methods to evaluate reduction may be used. Examination of closure in centric and excursive movements is mandatory. This shows the use of a bite tab, a gauged bite tab, to illustrate the amount of reduction. Other methods include a putty reduction guide or red wax.
Another common but significant error is failure to round sharp line angles. If working with the metal casting, sharp line angles are frequently seen to be rounded off due to surface tension of the molten metal. The subsequent casting must be adjusted to achieve a proper fit. In the case of all ceramic restorations, an area of stress associated with a sharp line angle may result in fracture and failure of the restoration. Line angles are easily rounded with stones or discs.
A putty reduction guide and a periodontal probe may be used to evaluate reduction. The reduction should be anatomic. That is, the preparation should look basically like the original form of the tooth. Tooth preparation can be a perilous operation requiring extreme care from the operator. One should learn how the preparation should look. Practice of the preparation on the dentiform is highly encouraged. The use of a putty reduction guide can help in gauging the amount of reduction, and the tooth should be reduced anatomically. It should resemble the original tooth in basic outline form. So this is Dr. Junior Poser and Dr. Marie Huggy thanking you for listening to the Dental Learning Center.